So let's take another look at another synthesis problem. Now this is going to involve alkynes and alkenes, so if you haven't covered that material, you're going to struggle a lot with this example. Now, to be honest with you, it's a lot easier to come up with the problems than to solve the problems. So as I was driving in trying to think of a good problem, I was like, oh, I could do this, 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 and then it occurred to me like, I'm kind of cheating because I know how I got from the reactions to the products. So I need to give you a video explaining how you would go backwards, which honestly, if you don't know how I made the problem, makes it kind of hard, right? So alkynes are usually going to represent a terminal step. If we're making an alkyne, we probably did a double elimination because it's not likely that we did a single elimination off an alkene to make this. So the most common way to make an alkene, if you see it, is to start with two halogens, either vicinal or geminal relative to each other. So once you see this alkyne, you got a couple options at your disposal. You can either be vicinal or they can be geminal. Doesn't matter. The point is that we've got two of them coming off. Now, the way you would do something like this to get them on the same side, and if you're probably thinking about it, is that you need to add something like HCl. Now, the issue with doing this is that this starts you back at the alkyne, which is what you want to produce. So this isn't a particularly useful scheme, so we're probably not going this way. Now, this we can accomplish by doing an X2, a Cl2 addition across a double bond. So if we just add the Cl2, we probably start with something like that. Now, there's also the cis isomer. What I've drawn there is the trans isomer. The reason why I don't think you'd really produce the trans isomer by any previous, or I'm sorry, the cis isomer by any previous step, is that that would put two very large groups of phenyl rings side by side. It's not likely, but in full disclosure, you probably had that as well. So is there a step that will take us from this to this? Because as you're probably starting to see with your eye, this is looking a lot like this. In fact, it's those two groups stapled together. So how in the world would you get that? And this would be kind of a challenge problem, particularly people who didn't have me for organic 1. That's a metathesis reaction. So if we take our starting compound and we add something like a Grubbs catalyst, or a Schrock catalyst to it, metathesis reaction will produce this plus the ethylene. So as long as we draw out the ethylene, this will be our predominant product that gets formed. From this, we do a Cl2 addition or Br2 addition, some type of halogen addition, to give us the dihalogenated compound, and then use a strong base, preferably a strong bulky base like tert butoxide, to remove our two halogens and give us the alkyne. So this is the solution to this synthesis step. Again, if you haven't covered alkynes or alkenes, this is not going to make a lot of sense to you. So kind of reserve this for one of those down the road kind of problems.